Hi, everyone. Glad to be here. Today's my talk's going to be on the leveraging large language model-based marketing, analytics, copilots, and agents. It's quite handy, but I want to cover all the keywords here just to make sure we get a context on what's being done. So it's the work being done at Adobe along with my team. So anyone who needs a quick LLM refresher, this is the transformer layer where we have embeddings, which is basically indexing of categorical variables into a numerical representation. And then we have self-attention, which uses the concepts from information retrieval, like query, key, value pairs, and then a softmax over a cross product of query and key, and then taking appropriate dimension. And then the multi-headed attention gives some sense of the importance of each word with respect to the other words. So the paper, Attention is All You Need, which came around 2017, has really moved the field of neural networks much forward in terms of the ability to scale and run the prediction of the next token at a much faster speed as well as accuracy. So because I work in the field of marketing analytics, maybe I'll put some context around why we use this. In marketing analytics, there's a bunch of different kinds of users, of different personas, mostly data analysts or marketing analysts who might not be very technical with the SQL or the data schemas, and they would prefer a language, more like natural language, so that they could focus more on the business domain. So something like ChatGPT over their data would be insanely useful for them. So with that in mind, they are looking for something that reduces the amount of human effort required to answer custom questions. And then the next reason is because there's even to create dashboards, you need a different persona, and it might take a couple of weeks to for them to create a dashboard for your requirements. And hence, they need something quick and more flexible. So having this will help them create quick dynamic dashboards beyond static ones. And then the third reason is something similar to the first two, which is, let's say I want to combine two dashboards and want that information as soon as possible, then it provides a quick lookup, which makes resolving challenges very quickly. So the problems with LLMs, again, the data is spread over different databases or knowledge repositories, and having put everything at one place might not fit in the context length. So over the last 2 years, the context length has increased significantly to almost 100K for OpenAI and 2 million for Gemini, but still they're slightly expensive because of context length, but still it wouldn't, the entire database wouldn't fit into the context, and hence it's still a limitation. The second one is hallucination. In enterprise, you cannot afford to hallucinate in terms of either revenue or any such details. So you absolutely need accurate information. And if it does return inaccurate information, then enterprise customers won't be happy and could result in huge losses. The mathematical illiteracy is one thing that large language models are struggle at, because they are absolutely bad at numbers, no matter how much data you throw at it. So even so for floats, where you have to do complex multiplications, etc. And there's the final challenge of interpretation difficulty that's been there for neural networks for a while. You do not know why certain output is produced, and that's one reason why they were not very much useful for marketing insights because of lack of interpretability. So again, just a quick refresher for someone who is the prompt engineering is something that we have been using for the last 2 years after the ChatGPT. Sorry for the formatting issues, but some of the tasks that the marketing analysts usually use is question and answering, like, hey, tell me what this means in my marketing domain. So that's question answering over the documentation. And then SQL query generation. Let's say I have 5 tables, one with the revenue, one with the customer data. Then if I have to generate a query, then my question should be rerouted to that. And let's say I want to gather a quick summary of what's happening in the data and some insights, then that's tabular analysis and so on. So we want our question to be routed to one of these tasks. And then for each task, we need to find the right context, edge cases, preferably what's the output format, and avoiding bias, and also properly give instructions and examples so that all of that could be combined as a prompt and fed to the pre-trained LLM model to give us the appropriate output. This is the basic and the easiest approach that most customers or most businesses use for simple use cases. And then comes the RAG, retrieval augmentation, which is the most commonly used across all the industries currently, where you just break down all your documents into chunks, again, because your documents are huge and they don't fit into context length and are spread everywhere. So you just have to split them into appropriate chunk sizes, use some kind of vector store, which has both semantic and probably even the exact string match, so that you could do both the exact keyword or the semantic search. And then use some kind of retrieval methods to get the appropriate chunks, and then feed it as the prompt like we did in the previous method and get the output. So the semantic search, the RAG approach has seen a lot of success, and almost most of the use cases that are currently powered are through the semantic search. The fine tuning is the third approach, which most commonly used when you have narrow domains or when you absolutely need even the flow and the tune of the narrow data that you are running upon. So here, basically what you are trying to do is you have a bigger, larger language model, but you want to change or update your weights so that it could fit to the newer data that you are bringing in, which is small labeled corpus. So there are few techniques to do this. The naive ways to retrain everything, which is huge, compute intensive and expensive. Instead, we could use something like LoRa or low rank adaptation, where we just train a smaller matrix, which will perfectly fit to the smaller corpus, and then update our original weights based on this matrix so that we get a perfectly fine-tuned model with much faster inference speed or even training speed. Even though we started with Copilots, over the last few months, we have seen good progress in terms of agents. So let's talk a little bit about that. So the agents, as we have seen, have evolved a lot, where we started with traditional AI in terms of just predicting some dependent variable, and then came the prompts. And then for the agent world, we would try to create or give agent relevant prompts, and then we expect the agent to do end-to-end automated behavior so that there's minimal involvement from the user. Over the last few months, we have seen the agent architecture has been broken into 4 parts, where it could potentially include the profile information, the memory, planning, and action. Profile and memory has already been included in some kind of RAG architectures. But the planning and action is where we have seen a lot of research, such as the chain of thought, and the React, etc., where there's multiple single path reasoning and multi-path reasoning, so that we could get better accuracy by more planning. And the latest O1 from ChatGPT is a output of these methods. And even the action space is where it could use a lot of tools, figure out the right tool, orchestrate between the tools, connect the tools appropriately, and chain them according to the use case so that we could get an appropriate output. So the latest advancements in this AI agent architecture framework is that there are some platforms which support multi-agent, multi-tools orchestration, where anyone could bring their own model, databases, agents, tools, and carry over everything for their custom use case. But this is where most of the players are trying to fit into. One is the data layer of where either it's the usage data like the Reddit or the action data that you interact with different platforms, and the memory layer, which is either something stored about me in the long-term memory, and then the personalization APIs, where I would want the output to only consider my past behavior or my past history, so that I do not receive irrelevant outputs. And then the mixture of agents is where a lot of verticals could be handled by separate entities or separate startups who are much more familiar with their domain. For example, healthcare, legal, and even the marketing can fit into that. And then the horizontal agents, where if for someone like Workday, which can fit into multiple domains, not just marketing, but so they could interact with the other agents and provide appropriate output. And then the orchestration layer carries the responsibility of moving between these agents and tools to get the appropriate work done for the user. Finally, the deployment layer is where some of the companies who had to directly deploy the application to the end user, either on the mobile devices or on the on-prem storage, have to make sure of these constraints. For example, the legal or health and other security, privacy sensitive sectors have to take care of these deployment layer. And then the inference optimization is very important in cases where let's say like an audio chat or a video chat with an AI, where you want quick inference and the latency is of paramount importance. Then there's a lot of scope for new startups to improvise there and help businesses come out with new use cases. And again, there's both individual users and business enterprise users. For marketing cases, it's mostly the business enterprise users that we care about. So now that agents are all the rage, some of the challenges that we see mostly in the adoption are safety and control. Like we aren't able to control what it provides because it does some unintended optimization because of what it's aligned to. So that's where we need to make some changes. Same with transparency and explainability as with any deep learning models because of the black box decision making. Over the last 2 years, we saw the performance and scalability has increased significantly, but still for uncovering more use cases, we still need some improvement there. And the ethical considerations have always been there. Depending on the person using your tool, you have to make sure it follows the appropriate bias and aligning with the user values. And finally, adapting to new situations. There's always new questions which were never in the trained model, and hence responding appropriately and not inaccurately is very important, and that's where the generalization is important. And finally, until we figure out a perfect way to do this, it's better to have a human AI collaboration for oversight. Some of the approaches here may not, all of them might not have worked, but they are just abstracted and proposed, like some audits and ethical guidelines and safeguards, either through prompt or through data ingestion, etc. And for transparency, mostly providing, like the chain of thought does, whatever intermediate steps through user-friendly interfaces. And for performance, maybe as we see more and more algorithms and inference being improved, we could see more cost-effective inference over the time, as we saw a decrease in 10x cost. As we see more and more agents, it's good to be evaluated against the common benchmarks. And for ethics, it's usually considering all the population that's using these agents, it would be good to define end-to-end architecture according to that, both the data input and the output. And the adaptation, some of the frameworks like Crew AI are trying their best to adapt to the new use cases through transfer learning and adaptive learning. So I'll quickly glance through some of the results through Copilots, mostly because they have, because it's been changing a lot. Compared to the open source models, the GPT-4 has been doing good, but that might have changed with the new llamas. And we have seen that for the embedding models, the text embedding models have done relatively better compared to the instructor embedding models. And for SQL query generation, the fine-tuned models have always done better, even when the open source ones weren't doing as great as GPT-4. For the tabular analysis, because it involves a lot of data manipulation as well as understanding of the numbers, etc. It's always the agent, like the LangChain pandas, where we could use the deterministic function to get the accurate output is a lot more realistic than to leverage something like GPT to perform any function-based calculations on your data. So closing thoughts, yeah, usually the large LLMs have been helping a lot, and we already see many companies like Adobe, Salesforce are using these for their businesses through AI assistants and agents. And the fine-tuning helps a lot, especially for SQL query generation. So most companies are fine-tuning for their own schemas. And specialized agents like Pandas agent, when combined with LLMs, will give the best performance. So it's combination of LLMs combined with agents. And the open source are definitely catching up, because the small open source models beat the closed large models, mostly because of the flexibility in fine tuning and the cost are the reasons. And any questions? Yeah. Right. So in the current landscape over the past few months, we see that a lot of small startups have the advantage of picking these open source models, at least the llamas or Mistrals, and then either it for fine tuning it for their own narrow use cases, narrow domains, or for their own languages. They have, or for custom use cases which are not usually catered by the closed models. So these are the situations where the open source models are really doing well. And we have seen some very interesting use cases, especially when they combine it with either hardware or robotics, where they have a lot more flexibility in combining it with different architectures. Yeah. Yes, there is an orchestration layer where one agent talks to other agent, and it's more like sometimes it's just a frequent, it could be a frequent communication with the agents, and sometimes it has to pick the right agent to make sure it does the right output. So yes. Yes, there's definitely a cost and latency associated with it. In enterprise use cases, sometimes it's okay to have even few seconds of delay, as long as there is appropriate value for the end user and the accuracy is good enough. They are happy to use this approach. Yeah.
What do you think? What do you think are currently the most popular agents, and in the next year, what do you think? What type of agents will take off? And Waymo, for example, is that an agent, a robotic agent? The Waymo self-driving cars?
Yes, I think I would say Waymo is an example of robotic agent where hardware and software are almost tightly combined. But I see currently the agents are doing pretty good in the coding and customer service, where I think the margin for error, even if it's high, the developers could correct it. And there's also plenty of training data for the agents to be trained on, leveraging the open source. Like I think Cursor was trained on Llama along with a lot of code, and it was doing extremely well. So in the cases of most coding tools, as well as the like use cases for Salesforce, like customer tickets, helping in Jira tickets, and maybe solving some quick bugs, they have seen the highest success. And even Amazon claimed that a lot of code was written by some of these coding agents. Yeah. Currently, it's an evolving space. We built our own orchestration layer, but as we see, there's a lot more LangChain and other tools. LangChain is heavily focusing on orchestration because the rest of the stuff is being taken up by other big players. So LangChain is a good tool for agent orchestration.
Sweet spot you found with your dimension size of your vectors?
It's usually based on the general practice the most industry follows, because it's a lot expensive to try with different vector sizes. We generally go with what's being most commonly used.
So, like are you going all the way down to like 64? Or are you going around 1,000?
For the appropriate use case, whatever fits, somewhere between 64 to 1,000. If there are no more questions, we can move to the next speaker. Yeah.
Thank you, Sai. Hi, everyone. I really appreciate all your guys sitting after hours after hard working day and listening patiently to so many new concepts and theories. So before I start, I want to wake you up all in case you got tired. How many of you here are engineers? Can I see by show of hands? Okay, that's great. I'm going to help you understand a little bit more deeper into similar concepts, kind of give glimpse into the architecture angle and the production challenges, and hope you get to take away something. Quick intro, I am Meghana. I currently work as Director of Engineering at NVIDIA for Enterprise AI ML initiatives. Prior to this, I worked at AWS Bedrock, which is again a platform which provides all the tools for accessing open source models, closed source models using inference APIs along with tooling platforms. So I'll be happy to connect with any of you if you have any questions on AWS Bedrock too. Today, I wanted to cover, since in the previous presentation, we understood a lot about agents and RAG. I'm going to quickly glimpse through those slides quick so that I'll come to the interesting bit quicker. I know Sai covered this earlier, but I kind of want to make everyone understand with a simple analogy. How many of you know what's the difference between an LLM and an agent? Are they same? Are they different? Are they subset of each other, superset of each other? What's it? Do you guys know any answers? Okay, I'll kind of give you a simple example. Imagine a brain as an LLM, which knows everything, how to do, what to do, reasoning, all the cognitive neural abilities. But just having brain doesn't let you walk, doesn't let you taste food, doesn't let you hear, and doesn't let you do anything by itself. LLM is like the brain, which has all the capabilities, whereas all the sensory organs that we have, eyes, nose, limbs, tongue, everything, will let you do the real actions, coordinating with the brain. So agent is like your body, which is able to make actions, do actions, whereas LLM is your brain, which can coordinate and make meaningful responses. Here is a technical representation of it. An agent constantly perceives signal from its environment, that is, takes in inputs, takes in observations, takes in state, and then maintains its own memory, and then uses a large language model as its brain before it can take the next action. And it goes on, does this in a loop continuously so that it will either conclude an answer for your complex question or finish a workflow or create an automation by using all the tools at disposal and using LLM as its brain. A brief overview of the timeline. I didn't capture all the important things, but these are some of the pivotal moments of how agentic architectures evolved. As you all know, ChatGPT came in 2022, which is the most famous and the popular one. But prior to that, the first paper about retrieval augmented generation, which actually takes in the power of large language model, came much before ChatGPT. Which is in 2020. And then the second most important invention after ChatGPT is the ability to act and reason. That is the agentic behavior that I mentioned earlier, which it constantly does in a loop, has come around 2023. And that gave an opportunity to several startups and cloud providers to come up with tool sets and APIs where you can build agents with agentic platforms. And now is the era where you build multiple agents, connect those agents, enable communication between them so that you finally get to a fully functional automated workflows. This slide is kind of what it does. Let me take you to another interesting image, which kind of gives you a very good mental mapping of what are the 4 pillars of agent. It has memory. It can remember things. Suppose you book an airline ticket in economy class. It can remember the next time, let's say you come after 20 days and you make another flight booking. It remembers that your preference was business class. So it'll prompt you, hey, I remembered last time that you booked this. Do you want me to book again in economy class? The second most important power, like I said earlier in the example where you have limbs to perform functions, you give tools, which are nothing but APIs, which can be search, which can be literally any data source or any functionality that you can invoke to perform an action, which is, here I just gave some examples. The 2 key tool sets that you could give agents for all the real world applications are, one is code generation and second is search. Search will let you power through real forms of data, which is like your websites, FAQs, PDF documents, SharePoint documents, anything that you have, which is real data. And code generation will help you do the deterministic actions, such as performing calculations, scraping through the file and converting from one format to other, getting things like what is the current date and time? How do I transform 2 days from now? Let's say today's date is September 24th. 2 days from now, you can write a code snippet automatically, which can convert this and give it back to the agent to process that input and give you a fully formed output. And the last important one, which was also covered in the previous presentation, is the aspect of planning. Planning and reasoning kind of goes synonymously, and people use it interchangeably. I'll go a little bit detailed into planning, but planning is mostly done by your LLM. Agent kind of just delegates the activity to LLM, but takes in the output to form the fully functional workflow. Okay, this is the most interesting one. I'm not repeating some of those contents which are already there. Within the planning component, the working piece which makes it to plan is the prompt strategy. There are various forms of prompt strategies, like I mentioned in the timeline slide. The most important ones at a very high level that would be useful to understand is chain of thought. That is, you give the ability for LLM to express the problem statement, break it down, express thoughts, create structured outputs, take in action, think again, emit thoughts, and create structured outputs. That is the most famous one, which is chain of thought. Revo is something that gained popularity more recently. It is decouple your planning component with your action component. Let's say we have a huge task like process all the claims and send reminders to your clients who has pending status. It will break down the problem statement. It will perform the action by calling the necessary API to get the pending claims. And then it will complete the planning without necessarily taking in the observation which is the tool output. This in some sense reduces the token count that you have to pass at every input, because you're planning once for all and you're finishing all the observations, and you're kind of using these observations along with the original plan to make a final conclusion. And the rightmost one, which is the most complicated one, it uses Revo internally, but it does a multi-step reasoning. Instead of having one single path of answer, let's say you have a gaming problem and there are several possibilities to win that game. If you want your agent to predict what are the 5 possible ways to win this game, it will find out all the possible paths, takes in output at each intermediate step, reevaluate, and compute the final answer. I'll skip this section since we already went over. Let's come to the real world use cases. Almost every enterprise, whether it sells a product, sells a service, would have the application to use agent or agentic RAG or multi-agents in every form and shape. The advice that I generally give to enterprises or the executive members of the company is start with the most simplest use case. In my opinion, the most deterministic and the most simplest use case is your new hire onboarding. Almost every company has to do new hire onboarding. And in new hire onboarding, you have a bunch of redundant activities which are very detailed in terms of how do you have your day 1 activities, day 3 activities, and day 7 activities. So you can feed in all that knowledge, replicate an ERC agent or a new hire mentor or buddy to behave the exact same way, to do all the checklist of things without you intervening with a human being. This is the most easiest and the most deterministic way you can see outcomes, and you can see productivity in less than a day. And the second most important thing, as a previous presenter already touched, was code assistant. Since you always have human in the loop for all the engineers, the easiest way that you could integrate an agent is to ask it to generate code which a human evaluates, so that you could have the final outcome which is verified by a human before you actually take it into the production. So that's the most interesting use case which almost all the enterprises follow. The third one is supply chain management. Let's say you have a product where assume you manufacture around 1,000 parts for a given entity, and you have to manage or create supply chain schedules or the delivery schedule across 1,000 customers. Imagine you give this inventory details, you give the demand forecasts, and you ask the agent, give me the 5 possible plans to deliver this on time and maximize my profits. So you could use the multipath reasoning, which I mentioned earlier, and you could have a human evaluate the possible plans from the agent before you ship out based on those delivery schedules. That is the third most easiest and highly productive task which you can ask the agent to do for you. The two dimensions which I feel are very important in agent space is how interactive they are and how complex they are. So on the y-axis here, you have complexity, starting from simple to complex. And on the x-axis, you have from interactive to completely autonomous, where you have no human. I have kind of given examples of what are simple and interactive ones, where you can use agentic RAG systems in order to do like information retrieval. And the most complex one, which in recent days gained popularity, was Devin AutoGPT, which kind of is completely autonomous. You ask it to build a website and you give a few feedbacks in between, and it completely builds it end to end, right from the application, UX, customer experience, backend APIs, databases, connecting it all together, and makes it like a fully autonomous workflow with very minimal human intervention. The different way of looking at agentic architectures, the most simpler one towards your left, which is a single tool invocation. That is, you just give the bare minimum where the selection process is a little, and you could almost easily automate because you're only giving it one tool. And then comes the multi-tool invocation. Within the multi-tool invocation, the most simpler one is procedure following. Like I said, if you have a very deterministic way of doing things, step 1, step 2, step 3, feed that data into the agent, which it can easily follow and use your multi-tool access and can convert natural language inputs to follow the procedure. And then human involvement, which is the code assist or code generation or unit test automation workflows that I mentioned, where you involve human to verify the outputs before you actually take in the final result into your system. And then completely autonomous, where you don't involve any human. Let's say you have a huge list of product ASINs. Imagine you are in charge of onboarding sellers onto Amazon website and keying in all the product codes and then sorting them by popularity. You could use the completely autonomous workflow where you give defined instructions that can follow the procedure, fill in the catalog, do the seller verification, and finally get a completely working set of sellers integrated along with the products, and then do the buy box winner and everything that goes on in the website without having any human involvement, because they are procedure following, multi-step, and specialist agent involved workflows. Here I gave one of the example, a very toy example, I would say, where you're saying agent, you're a customer relationship management agent who can help me, who can help a salesperson to plan and work with the customers. You provide the company overview, you have access to customer interaction history and customer preferences. So you give the instructions to the agent, which is kind of system prompt, as people say, and that feeds into the overall prompt, along with your prompting strategy chain of thought, where you give the APIs or tools that it has access to. You give the specification somewhat like this, where these are your APIs, these are your API descriptions, these are your API parameters, which feeds into the prompt. This is the second API which you give it access. This is again the second or third tool. And then you can, in one click with all the popular platforms, you can get a working agent which says, where you can interact with it, something like, hey, I'm working with this customer like AT&T. given our recent interactions, what are our top concerns or interests that we could sell to this customer? So if you see on my right, I don't know if you could read, but the agent which uses both chain of thought, plan and solve, and review together would get you an output like that, where it says, to answer this question, I need to first get customer ID from the question. Then using the customer ID, I'm going to call this tool called list recent interactions. And then I'll ask for top 5 recent interactions because you want the summary to be concise. And then it says, I will ask for the recent interactions to determine the top concerns and interests. And then finally, I break down into a summary, which you can publish as an agenda when talking to your customer. This is the same where I just highlight the final response. This is the explainability where I showed you the rationale of how it comes up with a plan, executes the plan, gets the evidence by executing the tool, combines the response, and then reconclude at every step and gives you a final answer. This is one more example, which is again for an insurance company where I gave 4 APIs, such as get my claims, process my claims, send pending reminders, and then I can automate all the claim processing workflows for an insurance agent, where all it has to do is just feed in the customer parameters or input parameters for those APIs. And then this is a combination of both action and RAG. So if you see at the bottommost, it says what, other than filling the actions or fulfilling the actions, it says what type of coverages do you offer? And then here, the agent intelligently knows that to answer this question about coverage, premiums, and policies, I need to search so-and-so knowledge base, and this is the query parameter, and this is the answer which it summarizes along with tool invocations. So these are some of the popular platforms for you to get your hands-on quickly. I would highlight the key difference is LangChain. If you're a developer or an engineer who knows how to code, I would say low code still, just have the API keys, plug in the model, and play with it to kind of get a sense of different prompting strategies. And if you're a product manager or a business manager who doesn't want to touch code, just click few buttons. You have a low code option in AWS Bedrock where you can just get in your API specs and just do a prepare, and you'll get agent within seconds. And then few more providers are Fetch.ai, Code.ai, almost you name the startup, everyone provides you an agentic platform. The best way to remember the tenets, this is one way, not, I don't know if this is the only way. Whenever you're building Gen AI applications using Agentic or RAG or Agentic RAG architectures, the easiest way for you to remember to follow a particular set of tenets is your data should be always fresh. So there should be a constant ingestion of data to keep it up to date, because your large language model is trained at a period of time and it stopped. So its knowledge is limited. So you constantly ingest the data all the time, and you make sure, I'll get to the security bit, but data ingestion comes with a lot of complexity around permissions, which needs to be carefully thought through, because now you're making your content so easily accessible. Previously, people must have had to get to the document by doing 20 clicks and 30 websites. Now, within a single line, people can access this content. So there's a lot of complexity in the permissions management. And then architecture. Make your architecture not bind to any particular LLM. Try to decouple all the components which I stated earlier, which is memory, prompt management, tool invocation, action executor, and planning module, as decoupled as possible, so you can swap in and out any number of models. And as you all know, we are getting a model every other week. So you should have your architecture which is flexible, such that you can swap in and out any model and test your components in a very decentralized manner. Cost economics, the bill of your LLMs is going to quickly add up. If you don't watch, by the end of the month, you'll pay millions, depending on the number of tokens and the abuse, how your customers are going to use the system. I would highly recommend to decouple these components and try and see where you can fit in small language models, where you can fit in fine-tuned models. Again, it comes with the caveats. Fine-tuned models doesn't allow you to extensively use newly updated models, because fine-tuning is a very complex and also time intensive and data intensive tasks. So I would give a word of caution before you approach fine tuning. Be very sure that this is an ongoing investment and you can't stop at once. And testing cycles. Now that you have large language models, small language models, and various statistical components in your system, having an automated evaluation framework is very much necessary. Having a clear test set is very much necessary so that you can measure the regressions and you can measure the improvement. Because for the same question, the LLM can give 10 variations of answers, like I said, in multi-chain prompting. For the same question, you would have 5 different ways of answering just with paraphrasing. So having a clear test set and a clear ground truth and a way of measuring the similarity scores using BERT score or using LLM as a judge is very much important so that you could automate your testing cycles. And finally, the security. Like I said, previously documents were hidden, it's hard to find, but now it's much more easier with agentic systems, which is why security plays the most important role. These are some of the challenges which again goes back to the tenets. Your latency and cost will quickly add up depending on the number of calls, especially with agentic systems. The number of calls, LLM calls you do at every turn quickly adds up, which accounts to both latency and cost. And security, every document that you have should have ACLs, that is access group permissions or user group owner relationship, such that you don't showcase content. For example, I remember one of the early chatbots that we created in one of my old companies, we exposed the pay ranges. Let's say you just ingested all the documents. Along with it, you have pay ranges for every employee ingested, and you didn't have access controls to that document. People can easily query, hey, what's the pay for my manager? How much do they earn? And you can easily give away the confidential information. The second most important thing is metadata enrichment. Let's say you built a RAG system where you wanted to ask questions about the code versions or things like what are the bugs in so-and-so component with version number 0.7. You need the metadata to be enriched such that it can answer more fine-grained queries, which are more component dependent. In the interest of time, I'm going to quickly show you. I showed you the RAG pipeline earlier. This is the production pipeline. So quickly, from a concept of RAG with this very simple idea, when it goes to production, can have almost, how many do we have? 14 touch points that you need to take care of before you can put in production, or you'll expose things like pay ranges. And then, as I mentioned earlier, the ongoing investments goes without saying. That comes in evaluation, data ingestion, permissions management all the time. And then here are some metrics for pointers of how you evaluate your systems end to end. I'll cover one last slide. As I was mentioning about a single agent, a single agentic RAG application, in the last 1 month, I would say last 1 quarter, the multi-agent architectures have been quickly evolving. And these are the 4 high-level paradigms where you have layered architecture where there is single direction flow of data, decentralized architecture where every agent can interact with any other agent, and then centralized architecture where you have like a master servant kind of architecture where the information is only to one centralized agent, and the shared poll messages where you can keep publishing the actions that you finished as evidence, and the central agent would basically have the authority to process the flow. This is one production sample pipeline. Yeah, that's all. Oh shit, sorry. Thank you. Yeah. Yes. Yeah, so in multi-agent systems, the fundamental concept is each agent is more opinionated and have a very shrinked domain. So in multi-agent systems, having it like fine-tuned for a specific domain data set. Let's say you have one single entry point agent and you connect to a HR agent, you connect to a sales agent, you connect to a supply chain agent, you can connect to a general FAQ agent. Fine-tuning each individual agent and fine-tuning the model which supports that agent will give you a lot more accuracy. And the second most important control point is the orchestration agent, which does the routing and which does the consolidation and answering when giving you the final one. Fine-tuning, I would say fine-tuning is not necessarily all the time for orchestration agent, but there more prompt engineering with more few shot examples would give you better results. Any other? Cool. Oh, yeah. Yes, almost every system that is built in production grade for enterprises needs guardrails. All the popular cloud platforms such as Azure, AWS Bedrock, or even GCP provide guardrails. The most important guardrail I would say to experiment is denied topics, like I said earlier. When you want your agent to be specialized in one particular set of domain or one particular line of questioning, having denied topics as your guardrails will prevent you, even if your permissions are not properly configured. It'll not give you 100% protection, but it'll give you statistically good sense of protection. Cool. Thank you.
Hello, everyone. And I know that I'm between you and the break, so I'll try to keep it short. So, hi, I'm Anup. I'm the co-founder and CEO of a company called VideoDB. And basically, we are building an LLM and large video model, an LVM ready video infrastructure. And a little bit about me, although technically I am an engineer, I identify more as a product designer, and that's what I'm at heart. And at this company, I no longer have coding privileges. So I hope you go a little bit easy on me. And I often get asked how we got to this idea in particular. And I always like to give the analogy of Amazon and AWS. So our team was working on a very easy to use video editor where you could use natural language, where it used AI to automatically take out filler words and all of that. There are many such companies now, but we are one of the earliest. And we scaled it to tens of thousands of customers. We are managing petabytes of videos every single month. And with the rise of that video data and video interactivity, the cloud bills started increasing like crazy, where it became no longer economically feasible to continue building a very successful and fast-growing product. So we had to build our own video infrastructure because we were enabling a lot of AI-enabled interactions. And we were able to reduce our costs significantly. And then it became just like AWS was built internally initially for Amazon. Now they started selling it to other companies. That is exactly what we did. So we started off that journey with an editor and then built and we are now selling the video infrastructure that we built for ourselves to other app developers. Right? And the title of this talk is Multimodal RAG for Video. And just off the bat, I'll say that for multimodal RAG, it is still day one. When we talk about multimodality today, it is usually on the input side, right? The input is multimodal, but the output is unimodal. And the most usable output is largely text. Most of the video outputs generated are of 5 seconds, 6 seconds. They're not really commercially usable, but so it is very early days in RAG, and all of us are still sort of learning and exploring, right? And AI is great with text, but for videos, especially recorded videos, simple requests are unsupported. So say for whatever reason you want to, you have a query, right? When is Elon Musk talking about rockets while smoking a joint, right? So in this simple query, maybe you want to make a meme or whatever. In this simple query, the AI has to understand the faces Elon. It has to understand an object, the joint, and then it has to understand the context of the conversation, which they are talking about rockets, right? But now let us look, like this is a fun, or like for whatever reason, you might have this query or you might not, but let's just look at a more serious query, right? So you were traveling, you had a bunch of packages delivered and one of them was damaged, right? And you have a Ring camera. So an obvious query would be, show me when the deliveries were made last week. I just want to see how the package was damaged. A very simple query. But now the steps that you have to go through to build this RAG system are, first, you have to transform the videos into a series of images. There's no real audio or text here. Then you have to use a vision model to identify objects, persons, actions. The vision model usually returns only the timestamps, right? So now the burden is on the developer to clip the different videos based on those timestamps. Then you have to merge all of them, and then finally make it consumable, as in stream them. So if you see, it is already a multiple step journey. So for video, RAG is not really just search and retrieval. It is more like an autonomous agent already. And because this is still being developed, we don't really support a lot of video answers yet, right? So that is one of the big reasons why video answers are still not popular. Now, the obvious question here is, what about multimodal LLMs like Gemini 1.5? I'm pretty sure version 2 will come soon, right? But Gemini also does only a small part of it, which is the intelligence piece, right? So it will transform the videos into images. It will help you identify the objects, right? It might give you relevant timestamps, but still the actual compilation, editing, and delivery has to be managed by the end user. Secondly, using a multimodal model is not really efficient, both in terms of latency and the cost, right? Because it is very easy to breach the token limit. This is an example of a 37-minute security camera footage, and it is already using around 700,000 tokens. So even if you have 2 million tokens, you will be able to support, what, 3 videos, right? So it is not really efficient. Again, the cost of processing these videos every single time is very expensive. So there is cost, it is very slow. And finally, all you're getting as an output are timestamps or descriptions. So again, you have to do a lot of work after that, right? So that is why RAG in general, just at a base level, is a better approach, because now what you can do is you can pre-process all of your content based on a particular use case. You can optimize that. You can then tailor the retrieval based on user query, right? You can figure out how you want to index it. You can play around with the parameters, how important it is to have hard cuts, like stuff like that. You will get you'll get better and quicker results, and you'll get lower latency in the responses. But most importantly, the cost is lower. Like as your video data, as you go into the data lakes sort of domain, the cost ramp up very quickly. Like I can tell you how many sleepless nights I have had trying to looking at the bill, and I was like, we can't survive this, right? So the cost is very important, and RAG is actually a much efficient way of reducing costs, right? So now if you look at a multimodal starter kit, I just wanted to give a generic architecture for those of you who are sort of thinking about building this or all of it. The first is basically the video input, right? You can from a S3 bucket, YouTube video, or whatever. Traditionally, what you would have to do is you would have to process the audio separately. Maybe there are claps, maybe there is other background noise, things like that. You'd have to convert that video into a series of frames. So you have to detect the frames and things like that. Finally, if there is a spoken component, you have to convert it into a text. You have to transcribe it. So you need a text processor. And then you would have to encode all of these modalities and then store them into a vector database, right? Like Pinecone or something. Today, this pre-processing is largely done by multimodal models, right? So you don't have to use separate processors and encoders. But then this is just only step one. right? Now you have to build a retriever where also you might use either a small model or a large model to kind of do the retrieval piece, right? But then you have to now rank the search results, because now here you're getting the output as timestamps, right? So you have to rank them, which is the most relevant, right? What is the length of it? Is it across multiple videos, or is it just inside one video? So all of that has to be figured out. And once you have done it, you have a video generation process, right? Which will actually, so this is a service like FFmpeg, which is most popular, which will actually do the editing, cutting, and then compilation of it. And then finally, you would use a streaming server, something like Mux, or again, Google and AWS have a lot of options around here. So again, this is sort of the multiple processes here. And if you see, the pre-processing and the video generation of files is extremely compute heavy. It is very slow process, and it is even the video generation, which is the most costliest process, because you have to transcode each file that you generate. So in the earlier example, if you got 6 clips of the person delivering the package, there will be 6 different files which will be transcoded separately. That will add to your cost very quickly. And the more queries are, the more number of videos, the more number of clips, and the more cost as a developer, right? So this is something that I just talked about, right? And usually we use a file system. MP4 is most popular. There are multiple depending on what your use case and what your data source is. But here the insight that we learned the hard way is that the more the number of natural language queries, the more the dollars that you will start spending, because the process of transcoding is sort of the hidden cost there, right? And this is when we started thinking about, what is the thing that we are missing, right? And the obvious thing that is often missed is that we are still working with video files. And as an output, we are still thinking in terms of video files, right? MP4 being the most popular. Now for data, we don't really work with individual CSV files anymore, right? We use a database. Then the obvious question is why in an age of AI and agents, we are still working with video files? Because video files were made for one particular reason, which was laid back viewing, not queries. You're on your couch, you're watching a video. The only realistic tool you have is a seek bar from start to end, right? And that is how you find stuff. And so video files are like an old storage cabinet, where in a way each frame is sort of a file, right, that you're going through sequentially using the seek bar. Then you are finding stuff there. If you don't find something, you're closing that drawer, opening the other one, and then finding it. So this is very inefficient process, right? Because now, even after you find things, you're now creating more files, which again, so it is a problem that keeps on compounding, right? Because each file that is now created has to be stored, it has to be separately streamed, and things like that. So we basically, what we need to do is we need to reimagine video as data, right? We have to reimagine video as data and not really files. We have to move from the sequential access file cabinet side of things to direct dynamic access to different modalities, right? And that is basically, there will be multiple approaches to this. So what we have, our approach is to actually make it analogous to that of a database, right? So we sit between the layer of your LLM and your video library. And we pre-process all the video data that you have. And we basically give the LLM the tools to search, personalize, and stream the videos instantly. So now you can enable video answers very quickly. There was a formatting issue. I wanted to show you some use cases, but there was a formatting issue. But we can imagine for our customers, or what we are really excited about are certain use cases that feel very impossible today. like just video answers in chatbots, right? So in enterprises, there is a lot of onboarding, there is a lot of information that you want. You just ask a question, and if there's video, you can just watch the video, right? Personal highlights. Hey, show me highlights of last night's football game, right? So now these are the kind of things that we are enabling. Real-time content modification, moderation, right? Hey, I want to listen to Joe Rogan's podcast. The kids are with me. Beep out the curse words, right? So you don't need two separate versions, one without the curse words, one with the curse words. Now you can just have one, and it can be dynamically changed on the fly. Right? So there are multiple exciting use cases that are happening. And what we are excited by is, making video the first-class citizen in the AI world. Right now, text is first class, it gets all the love and attention, but we are hoping to give a little love to videos as well. So that's me. I'm Anup, and I work with VideoDB. Thank you. Yes, any questions? Yes.
Do you guys also do active speaker detection? Because this is the use case that
yeah.
Wherein the video is the horizontal and you have to convert it into vertical.
Right.
But the active speaker detection libraries, they are not that.
So we work with partners on the intelligence piece and the transcription piece. So the answer to that is yes. So we have multiple, speech to text companies that offer diarization, and then we can choose it, or we give the developer the choice to select which one they want to use. Yeah. Yes. So detecting the face. Sorry, I misunderstood your question. Yeah. Yeah. Yeah.
So what we want is, suppose there is an annual discussion.
Right.
Okay. And now there are, out of 4 people, 1 is speaking.
Correct.
So we want this frame to be in that person, like vertical.
Right. Right. Yes, absolutely. So that is what we support. So you can upload the faces as an input, and then we can do the rest, and you can tune it, right? So sometimes if the face is not there, it might not detect. So you can change the parameters. Yes. Yeah. Sorry? Yeah. So what we have, so we don't really convert it to text. What we have done is we have built our internal, media format that takes care of the transcoding and the decoding, the encoding and the decoding piece, right? So it is an alternative to formats like MP4. We never really expose that format to the end user. Right? So you don't have to download anything of that sort. What we are doing internally is we are converting the MP4s into this internal format that we call SPXT. And that is how, so that format is, which is now then streamed or converted into a streaming format like HLS. So yeah, I'll do it. Yeah. Right. So in terms of like the details of it, I think, my co-founder would be a much better person to chat with. I'm happy to connect you with them. So the main basic insight there was like, if you really go deep down, it has like a lot of Apache Spark and distributed computing and all of that. So the best way to think about it is right now, the file formats make it compulsory to essentially encode that entire file, right? What if you could just encode certain frames? And so basically, instead of doing like a batch processing, we have basically figured out a way on how you can, encode only the bits that are needed. And the easiest, like a relatable example is, instead of thinking of different files on your iPhone, what if there was one infinitely long file and you're just pulling content on demand, right? So that's sort of, yes. Yeah, so the mission statement is we want we want to make it easy for both AI models as well as developers to search and stream video as easily as they do text, right? So yeah. So there are a couple of challenges. The first sort of challenge is because this is such a broad technology, we have an input of customers from multiple verticals, right? So how do you prioritize which ones to go after? Like, should we go after surveillance data first, right? Or should we go after the media industry first, right? With a small team, we have to prioritize. So that, I think, is a big challenge that we are addressing. Secondly, it's not really a challenge. It is a question of optimization. Is basically using it for real-time video, right? So that's the next phase. That so it's not really a challenge of innovation; it's a challenge of optimization. Yeah. Yeah. So I think the overall outcome would be same. In a way, the outcome what we want is video sort of is like 80% plus of the content on the web, right? How do you make it a first-class citizen, right? Is where most of us enjoy videos, we consume them a lot, we learn from it, we watch it for fun and all of that. Making it a first-class citizen, I think, is necessary. So we like the broader outcome is we want to build sort of an important piece of internet infrastructure rather than just, yeah. Thank you. Yes. Right. So if I heard you correctly, the question is, are we training our own models? Yeah. So we are not really training our own models. We work with other models. So what we like to say is we are a video infrastructure company and not a video intelligence company. So we think that the models, like say the next version of Gemini or GPT, is going to be much better at understanding video, right? Once the video is understood, what do you do with it? How do you make it more consumable? Like that's where we come in, right? And for example, we work with a few text to video foundation models as well, because now we help them with their data prep. And once the output is generated by even a text to video, it's still an MP4 file, which takes time, right? Right now it's 5 seconds, so you don't notice it as an end user, but once it gets longer. So yeah, so we don't work with, so we are not training our own models. We are not in that game as such. So we work with any models that developers are working with. Yeah. 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 Correct. Right. Right. I think that is a really good analogy to think about. It's basically like a vector and similarity and things like that. The difference basically is in video, you actually want to see the output as well to see, then it's usable, right? In other modalities, especially text, you get the text output and then it feels usable. You can see it, all of that. But that is exactly what it is. So we do have like semantic search and keyword search and things like that. And the difference is we actually return back video streams, right? Yeah. So yeah, I think thank you so much.
Hello, everyone. I'm Prajakta. A little background about me. I'm a senior machine learning scientist at Walmart in the recommenders and the personalization team. Prior to Walmart, I worked a lot on computer vision. So a lot of video processing, image data. I wanted to try my hands on in recommenders. So that's an excellent space. I feel in AI, you can touch your hands on a lot of interaction data, NLP, also computer vision. And I personally, once I grow more mature in my career, I want to work in climate space. And I wanted to start building my portfolio. So I also volunteer my time in a nonprofit called Reworld. And I'm going to walk through a small AI initiative we have for Reworld. So a little background about Reworld. it's a nonprofit with approximate 50 people spread across the globe, most of them in United States. So people are like you and me. There are developers, there are ML scientists, there are UX designers, marketing people, all writers, market sales and stuff. We support another nonprofit in South America who do the actual groundwork of reforestation. So keeping that in mind, so I'm going to talk about fundraising design. So fundraising for profits and startups is, I wouldn't call it pretty standard, but I would say more structured, and it's easier, it's a VC path or crowdfunding, and everyone knows that you will get something back. You'll get through market share, equity, you'll get your money back. But what about nonprofits? Nonprofits, the return is only an impact with the society. So people not only at Reworld, but a lot of other nonprofits spend a lot of time finding matching donors. I'm going to talk Reworld's use case. So they are into reforestation. Now they have to, like last year, they had an initiative. They bought a land in Colombia, and they had to spend months and months finding the right donors, matching the persona, reaching out to them, and they're all volunteering, right? So they don't have that much time and that much resources. So how about fundraising chatbot for nonprofit? That's what I'll be talking about. Okay, so a little overview. What is a fundraising AI chatbot? The stakeholders are nonprofit people. I want to find a set of donors. I'm going to give my input, and in the simplest way, I should get the donors or family foundations who are willing to give certain X amount of money for my case. So now the design is pretty simple. So we'll have a chatbot interface. We are going to go through a very detailed model design in the next slide. So I'm just going to quickly skim here. So I'm going to put in, hey, I want X amount. It talks to the front end. We go to the back end. I'm going to use an NLP model to get the closest matching donors. And we also keep maintaining a data pipeline, which I'll be talking further. And in the result, the user should have the best matching donors or grants so that it just eases out the time and they can spend more time in writing grant emails and stuff. So coming to the main architecture. So I say, hey, I want $100,000 to fund a reforestation project in South America, plant 10,000 trees, save the species, support local communities. So how in inference will the chatbot take? So the system is going to ingest the user input. It will prepare it for processing. And I am using BERT. So just a little background about BERT. BERT works on a transformer architecture. It's excellent and the state of the art to solve NLP problems today. And I'm using Distill BERT. So it's pretty fast to train and you can fine tune for your own use case. In our case, it's fundraising. So before sending to BERT, in the space of NLP, it's important to take out the noise out of signal. Now, I don't want the stop words. I want to give only signals. So the tokenization and the text processing will give us only the important features. And then the BERT model will interpret. So in the background, we definitely fine tune it. And also BERT is still capable and cheaper to fine tune. So it's going to extract the features. In this case, it's reforestation, South America, funding 100,000 and plant. We have a user embedding. Now, I need to find the closest matching donors. So what we do is We have our own donor and grant embedding. So for initial purposes, we use web scraping, and we got a lot of donor information through grant orgs. And we created our own embedding. So that's what happens is we'll have our own embeddings processed and saved. So, and we do a periodic batch update. So a use case like this doesn't need a frequent update. So we can use it at a leverage and create a faster interaction system. So once we have our embeddings already saved and the user comes in, user has its own embedding, what we need to do is to write a similarity function. I am using cosine similarity. So it will get me the most matched semantic grants, get it to the map it, and we'll have the output. Now we're going to look a little bit into more detail into how we use these grants to re-rank further. So until this stage, I'm going to have the outputs only that match closely semantically to my user input. So very similar to the embedding. That's what the computer is understanding right now. But I want to diversify a little. What if I get all the grants from the same location and the same price? What if I want some grants which are also lowered or high? What if I want some grants which have some prolonged date? So that's called diversification, which we'll be looking at. So why diversification matters? Like I said, we don't want redundant information. We want the best grant donors from different aspects. Now, for now, we have a deterministic algorithm which uses the factors. The first factor is still the primary semantic score, which we got from the BERT. And the next would be the funding amount. So it's okay if we don't get all 100,000, we can diversify. That's like a small variable we keep. And geographical relevance. We also want the deadline proximity, like I mentioned, and we've kept this pretty flexible. For future use case, this would be more of an intelligent system. So keeping that in mind, we are in MVP stage and we are using in-house, getting feedback and reworld. We plan, once we are very confident about it, we plan to make it open to other nonprofits. And in terms of future enhancements, in terms of tech space, so anyone interested in volunteering that time, we're looking for data engineers. Because right now we're using a very simple storage embedding, but we want to try out vector indexing, we want to do pre-filtering, we want to cache frequent queries. We just want to optimize the data side much more. There's a lot of scope there. And on the modeling side, right now I'm using a very simple cosine similarity. It's powerful, but we plan to try, we'll benchmark it, and we plan to try something like approximate nearest neighbor. Short definition, it finds similarity in a high dimensional space. So it captures all signals. And that's what we would want. And like I said, my diversification logic is pretty deterministic, but we could come up with something more advanced, like an advanced clustering method, or something more efficient. So why this matters? Again, reiterating, we are volunteers, we all have day jobs, but we still want to support the impact, and we want to save time. We want to get as much faster donor access so that we can spend time on writing grants and stuff. And in long term, like I said, we would love to make it open source for other nonprofits going forward. That's it. It's pretty short and simple, guys. Any questions?
Hi, everyone. I'm Shradha. I'm an engineering manager with Adobe, and my team works on GenAI solutions for enterprises. Today, I will talk about a GenAI tool we worked on to create personalized video ads at scale. This work was done during summer of 2023, so the references would be around that time. I know the space has moved very fast, so don't put me on that. So this is the agenda of the talk. Let's first delve into the motivation. We are in the era of hyper-personalization. Gone are the days of one size fits all. Imagine you are Alex, a forward-thinking marketer at a shoe company, and you want to target the young audience, which responds is better to video ads. Being a modern thinker, Alex recognizes the power of video ads, which are personalized to individual preferences for targeted marketing. However, Alex knows that working with the creative agencies will take days, if not weeks, and would be very costly. And hence, it would not scale to meet the creation demand that personalization requires. But what if Alex had a secret weapon? Imagine a GenAI tool that could take a single marketing video from the creative agency and effortlessly adapt it to fit individual preferences. And that's where our tool GenVideo comes into picture, which helps Alex to create personalized videos at scale and at a fraction of cost. GenVideo takes a source video and a target image and a text prompt and replaces the protagonist in the source video to depict the object in the target image. Let's look at some examples. For a video depicting gray shoes, Alex can replace these gray shoes with either black or red shoes based on the individual preference of the customer. GenVideo can also help in culturalization. For a sweatshirt ad, a person wearing a sweatshirt can be chosen to be an appropriate celebrity based on the demographics of the customer. And it can also help in reducing workload of shooting product videography when a new product is launched. Now we will look into the related works. For background, let's quickly talk about diffusion models. Diffusion models define a Markov chain of diffusion steps to slowly add random noise to data, and then learn to reverse the diffusion process to construct desired data sample from the noise. Since images are quite high dimensional, it's very difficult to train diffusion models in pixel space. And hence people use a VAE to convert images to latent space and train a diffusion model in latent space. This is the core idea behind stable diffusion model, which is what we use in our work. Stable diffusion model is usually composed of a UNet with conv layers, cross-attention, and self-attention blocks. Now we will look into the related work for video diffusion models. So there are generally two types. One is video diffusion model where we have 3D UNet. At that time, when we did this work, there was no publicly available models, and these are very resource intensive, so we did not pursue this direction. The second direction is that you inflate a text-to-image diffusion model using a temporal attention module. So you just add a temporal attention module on top of the T2I model. So this is what we used in our work, and there are state-of-the-art in this direction as well, which is tune a video and make a video. So this is just depict that. Now this is example of tune a video. So basically in inflated T2I diffusion models, there are two types. One which allows conditioning only on text. So now there's the obvious shortcoming that you can only condition on text. And the second shortcoming here is that it is unable to change the shape and the style. It is asking to Starbucks cups, but it's not being able to. And the second is where they allow you to condition on image as well, which is a make a protagonist. We work, our work builds on this work. So this will be used as state of the art for our work. Now in this one, as you can see, there's poor alignment with the target image, and in where we want to change. So for example, if there is a car video and in the target image, you have a bus and you are trying to change it to bus, the shape cannot change. The shape continues to be what the shape of the source video is. Now let's talk about our approach. So at a very high level, our approach is divided into two stages as any modeling approaches. First stage is training and the second stage is inference. In the training, we take our base model and we just fine tune it with one source video. So it is one shot training. And in the inference, we condition our fine-tuned model on target image and the target text prompt. And with the help of embedded mask and the feature flow, we are able to generate a target video which follows the target image shape and identity. And I will delve deeper into all of these stages and then what is embedded mask and feature flow. So let's first talk about the training stage. So where we fine tune our base model on source video. So as a base model, we are using inflated stable diffusion unclipped model. So basically we are taking a stable diffusion unclipped model, an unclipped model along with text prompt conditioning. They also allow conditioning with image. So, so they have two conditioning, one is text, one is image. And when the inflated version has temporal attention layers as well. So you can see 3 layers here. This is the self-attentional spatial temporal attention. This is the cross attention, which is for text conditioning. And this one is the temporal attention. So this is the one which will somehow encode the temporal dimension of the video in a T2I model. So that's the idea of an inflated model. So we take this model. Now this one, which is the temporal attention, this starts with random weights, and we are keeping everything else frozen. We are only training the attention blocks, and we are also keeping the KV part frozen for spatial temporal and cross attention. Right. So this is just one shot training. Yeah. After that, the second step. So now we are on to inference. And remember, I told you that during inference, we have 2 approaches. One is embedded and second is feature flow. So I'll first talk about what embedded mask is. So basically, because the shape of the target image might not be same as the source image, which is one of the shortcomings of the state of the art. That's why we have to inform the model of where the region where it should place the target object. Now to do that, what we do, we take our fine-tuned model, which is the inflated ST-unclip fine-tuned, and we make 2 passes to that fine-tuned model. So in the first pass, which is depicted in the top branch, we are taking the target text and the target image. And in the second pass, which is depicted in the bottom branch, we are taking the source text and the first frame of the source video. And now at each time step, we compute the differences of the features. Now, this basically kind of able to get the region of where the target object should be placed. And we take these differences, we average them and binarize, and that gives us a coarse mask where the target object should be placed. Yeah, and in the final step, so this is the inference where everything comes together. So now we take this fine-tuned model. We have source video, we have target text, and then we take the embedded mask. Now this embedded mask basically tells the model that the foreground should be taken, the mask part where the mask is on should be taken from the target image, and the rest should be taken from the source video. So the background comes from the source video and the foreground comes from the target image. So that's the goal of introducing this embedded mask. And then we generate a video. Now, till now, we haven't talked about feature flow, so that will come next. So till now, to make sure that we have temporal consistency, we only are using temporal attention block. Now remember that it's only trained with one source video, so it's not enough. So that's we see a lot of inconsistency, and that's why we need to introduce explicit temporal consistency. So what we do is we introduce something called feature flow, which is based on optical flow. So the idea is that for each frame, you take features from the previous frame and the features of this frame, and you do a weighted blending of the features. Now, this is done only at a specific block of unit, as there we see the error is less, and I will skip the details. So just the timing, our approach training takes 30 minutes for each source video. So you have to do that for whenever you have a new source video. And for each inference, it takes 5 minutes. 5 minutes for an embedded mask, and generation is 10 minutes. So overall, it's like reduces the time. It's only 15 minutes, and while working with the creative agencies will take weeks. All right, so for evaluation, we are using 2 metrics. So one is clip T-score, which is basically just to measure the alignment of the generated video to the target text prompt. And it is very simply a cosine similarity between the clip embeddings. And the higher is better. And the Dino score, to measure the alignment of generated video to the target image. It is the cosine similarity between the Dino embeddings, and higher is better. So here we are comparing with our method with state of the art. State of the art here is make a protagonist. So you can see that our scores are better. Here as well. So these are just some results. I'm gonna go through these. So like, especially when there is a shape change, you'll see like make a protagonist does pretty bad. And here we have just done some ablation studies where we are showing that how feature flow is useful. So if we are not using feature flow, you can see it basically some details about the object starts losing, for example, logo and things like that. But with using feature flow, we are able to get those back. Yeah. So the limitation is basically the base model, which is ST unclip. A lot of the artifacts can be improved by just using a stronger and better base model. Our method, because it's only trained on one source video, it cannot generate entirely new motions. And future work, we want to use this approach with image condition video diffusion models. Yep. Thank you. Any questions? This one? Yeah. So basically what we do is we take a block one, it's a unit features. So there we see that the error is less between. So, I mean, so the frames which are generated, the error, because as I showed right in here that you end up losing the logo. So the error is more in the output and less in the block one features. So that's why we pick that particular block. And in that block, all the thing what we are doing is we are taking the features from the previous frame. So for example, here, this is the features from the previous frame and the features of its own. And then we are using a blending between the two of them to get, blending is like just take a weighted average. So like some W1 of features of frame I minus 1 plus W2 features of frame I, and that gives the features. Yeah.
So if you want to keep it track really well, let's just say some kind of object comes in. So let's just say like the example where the start of let's just say the hand away for a second and it comes back. Will it be able to track that?
So I think it will keep the, so for example, because hand is not the object on not the protagonist, which we are trying to replace. So I think it will try to keep it same. But as I said, it's like, it's very early. So we have used ST unclip models. It's kind of, it's like 1 year ago and you know, the space moves really fast. I mean, like it's not that good, but it's just limited by the base model. So I would say maybe, maybe not, but can't guarantee at this point. Yeah.
So the inference time is 50 nowadays.
Right.
And that should be a good chip, right? So it's like
No, the chip here is just A100, just one A100.
Yeah, so we can enterprise it.
Yeah.
But it's like transform the architecture, remember like it's something that
Yeah. So right now in the space, in this field, we are using DIT, like diffusion transformers. So to be honest, that's why in the start of the talk, I said that it might not be relevant anymore. but the approach what we have contributed can be applied as on a DIT based model as well. So I think with the DIT based model, it might do pretty good. Thank you, guys.